Alright guys, welcome to my video. This is on the reaction timer for ECN, whatever it is, digital logic. The first question to be answered here is how do I generate a 100 Hertz clock given the 50 megahertz clock on the DE0 board. And so basically what I did is wrote down my code here, and some important things to note is how I increment my Q to Q plus 1, always at the positive edge of a clock. And the business end of this is right here. So if Q equals 250,000, I'm going to take my clock out and pretty much make it the opposite. And what this is doing is giving me this 50% duty cycle. Right here is the initial, and then it goes up here, and it's really key to have the upper the same as the lower. That's the definition of a 50% duty cycle. And I should have pointed out at first, but basically when I call this module, all I'm putting in is the 50 megahertz clock right here, and I'm putting out the 100 hertz right there. And as you can see, that's my input and clock in, and then I use a 17-bit register to do this. Alright, the second question is how do I implement my BCD counter, and this is my module and code for that. I have my module BCD counter. I take in the 100 hertz clock here. Alright, there's a clear, this would be the enable, and then we have our three BCDs right here, which are actually wires in the main module. And this is pretty explanatory. I'm just declaring my inputs, and then I have an output reg, which is 4 bits, which is what you would need to display the hexadecimal digits. Alright, same thing right here. Always at the positive edge of a clock, and right here I do if not clear. The reason for that is that there is the buttons on the D0 board go low when you press them in, so if you had it the other way they'd always be sitting high and it would always be on clear. So that is the reason for that. And so we initially set the BCDs all to equal to 0. Alright, and then when we enable it, we do something like this. If the BCD 0, which is the hundredths of second, and the BCD zeros for the tens of second equal 9, we're going to set them both back to 0, and then we're going to, just as a nested if statement, if the BCD 2, that should be a 2 right there, which is for the seconds, is less than 9, we're going to count up and increment to 1, else it's going to go back to 0. Basically all that is making a modulo 10 counter. The output here are reg, become wires in the main module, which were put into 7 segments, which I'll explain a little bit later when I show you the outline of my main module. Okay, the third question is how do you do the 7-segment displays? This is pretty straightforward, straight out of the book. Basically you make a module, 7-segment. It takes in the BCDs, which are 4-bit wires. Yeah, 4-bit wires that just came from that BCD counter. And then you have the output regs, which are 1 through 7. Yep, 1 through 7, because you need 7 bits to show up on the display, and those are LEDs. And basically you make a case statement, as you guys saw in the book. The big difference though is that on the DE0 board the LEDs are active low, which makes it so you know to display the 1 you would have to do 6 zeros and 1 1. No, I'm sorry, this is the 0, 6 zeros and 1 1, which corresponds to what you see over here. So the way the LEDs are put into the board, you have 1, 2, 3, 4, 5, 6, 7 being in the middle. So if I wanted to do 0, I would have to make all of these low. 1, 2, 3, 4, 5, 6 would have to be low, and then 7 would have to be high. And I gave a couple more examples of like how you would do the 1 digit, and the 5 being one of the harder digits to do. Okay. The way I called these in my main code is definitely I just do seg7, and then I named it like seconds, and then I would put in the BCD2, which is wires that are outputs from the BCD code that I just showed you, and the outputs would be hex, which are output wires in the main module, which is just like what I put here. And I have to call this 3 times, once for seconds, tens of seconds, and then hundreds of seconds. Okay, now how I did my random time generator. This is kind of, I think I did mine a little bit different than most people did. Most people did a LFSR, or some sort of random number generator, where they caused it to output something and then count either up or down to that number, to that random number. What I did is I had a normal counter going, and it counted from 0 to 1,000, and basically when it would reach a certain number, I think I used 243, it would give just a little blip just like this, which would cause this to go to 1 if and only if my start button was my start button was already placed to high over here, which I'll explain a little bit better later. But once that puts an output here, this is designed to hold that output, not just see this little blip and go high for a little bit. It actually holds it, which then turns on my LED and initializes my or enables my BCD counter. And the way this actually works is there's no clear on this, as you can see. It just sits there and rotates through it, and it goes from 0 to 1,000 back, 0 to 1,000. And what makes it random is actually where you push it. So if you happen to press the button and you were currently at this point, you would have to go all the way back through until you got that 1, you know, and just like as if you were doing it from here. Obviously it would take longer for that output to come if you started here or here than it would if you just if you hit the button at this time. It ended up working for me. Most of the time I get an output somewhere in this range. I should also establish that it actually takes from 0 to 10 seconds, because I have 1,000 digits and a frequency of 100, so I have a random period of anywhere from 0 to 10 seconds. And that's how I got the random generator. It worked out pretty well. Like I said, most of them end up being in this region, but it's still every now and then you'll get one over in here in this region. Alright, next thing is the state diagram. Pretty simple. In state A, you're waiting for your start button. Once it's pressed, you go into state B. This is where the random generator is happening. And then as soon as that random generator hits its little blip there, you go to a Z equals 1, which means the LED is on, and the random time and the digits are rolling. So this is when your time is starting to display. Then you come down here into C state. This is you pressing the stop button. I should have put that on there, but you press the stop button. Alright, count the displays. The count is stopped and the displays are stopped, and it shows your time. And then important is if you press clear from any of these stages, it turns this back into state A. There's no way to go back to state B, and everything goes back to A. So that's how that works. Okay, drawing over state diagram. Okay, this is how I implemented my code. It's just kind of a basic outline. I got over 200 lines of code in this, so I didn't really want to have to show the whole thing, and plus it's kind of hard to see on the screen. So basically I just had my main module right here with the inputs. You know, I had a bunch of wire, like my inputs were obviously the clock, the 50 megahertz clock, stop, start, and clear, all this, blase, blase. And then my outputs, a lot of them were the hexes and the LED. That's basically the only outputs you have to this. And within this main module, I would call things like, say, my 50 megahertz to 100 hertz module within this module. And of course you have to name it, and then you just put in the wires. Like so for this one, this was my 50 to 100 megahertz. I just put in the 50 megahertz, and then out came the 100 megahertz, which was actually a wire in this module that went into, say, my that was actually the clock for my random generator. Okay, and then I would end the module, of course, after everything was called, and then I had my little sub-circuits down here as modules, and they worked as on their own. It actually worked out pretty well for me. And to give a little more kind of detail of what I did, this is a block diagram, It's kind of hard to understand. It's kind of all hard to understand, but basically you press the start, and this module, because I used the buttons, not the switches, you had to build something that would hold the value, and basically I used the D flip-flop that had its Q routed back to itself. That way if you pressed it, it would you know, it would go high, and then when it wanted to go low, it was already OR'd back to itself, so it would stay high until I cleared it with my clear switch. And I think the meat and potatoes, the kind of more interesting part is how I did that. Like I said, this is my random generator. So this would go to a 1, and it would sit there and hold at 1 until this goes around. It's sitting there circling, sitting there circling. I should go put this at the 100 hertz clock. Yeah, everything's positive edge. And it just sits there in circles until it hits that blip. And this has that same control module. So even though this goes high for only, you know, a 100th of a second, it holds that high. And this is where the LED should be, right here. Yeah, great LED, Chad. And it starts bleeding, and that also enables this. And you can see that this is enabled by that control right here, which is all run off of this, and I have another one of those control modules, which is just a flip-flop that is connected to this stop switch up here that enables this, and I can stop it with that and clear it with it at any time. And then of course this is my BCD counter going at 100 hertz, and these are my 7-segment displays. Overall, this is pretty fun. Here's a demonstration of it working. I'll try to cover this so you can see a little bit better. So initially, let's see, yeah, it's kind of hard to see the digits, but you'll get the idea. So I press the start switch, some random amount of time goes by, and then, come on, bam, it goes like that. That was 0.5 seconds that it took me, by the way. I'd probably be a little quicker if I could fit my fat thumb under that plexiglass, but that's what it is. And you'd see, oh good, that was actually one of the shorter ones, so it took me 0.7 seconds. And you know, it just happens at random times. So overall, enjoyed the video. As far as the histogram goes, I kind of talked about it already. I have anywhere from 1 to 10 seconds, so it does pretty well. Overall, thank you for watching the video. Please grade well.